In Activity 10, From Liquid to Solid, students observe what happens to water and butyl stearate when they are cooled. The students learn that freezing is the change of state from liquid to solid. You will need the following materials from the kit: Activity Sheet 10, 1-ounce plastic cups, plain tumblers, butyl stearate from Activity 7, pails, roll of masking tape, and plastic trays. You will also need to provide crushed ice, 2 long-handled ladles, black felt tip marker, paper towels, and tap water. To prepare for Session 1, make a copy of Activity Sheet 10 for each student. Fill each tumbler about 1/3 full with water and set out the plastic trays for students' cups of water. Each team of 2 will need a 1-ounce plastic cup, a tumbler of water, and a strip of masking tape. To begin Session 1, review Activity 7, in which students changed ice and butyl stearate from a solid state to a liquid state by adding heat. Ask students, do you think you can change water and butyl stearate from liquids back to solids? They will probably suggest cooling the liquids to change them back to solids. Explain that in this activity, students will place water in a freezer and observe what happens. Next, hand out a copy of Activity Sheet 10 to each student and distribute the materials. Instruct each team to write their name on the strip of tape and place it on their cup. Have students then pour water from the tumbler into the cup up to the 20 cc mark and place their cup on one of the trays. Tell the class that you will now place the trays in the freezer overnight. Encourage students to observe that the state of matter of the water in the cup is liquid. Ask, in which state of matter is the water in your cup? Students should all respond liquid. Then ask, in which state of matter do you think the water will be tomorrow? Students should say that the liquid will be in the solid or ice state. Have students record their predictions on the activity sheet and place the 1-ounce cups in the freezer overnight. To prepare for Session 2, place the sealed bags of butyl stearate in a pail of warm water so the butyl stearate will melt and remain in a liquid state. Note that although it is non-toxic, butyl stearate should not be ingested. Just before the activity begins, set up a distribution station with 3 pails of ice water, 3 pails of very warm water, 2 long-handled ladles, and paper towels. Also, right before the activity, retrieve the team's cups of ice from the freezer. Each team of 2 will need their cup of ice, a tumbler, a bag of liquid butyl stearate, and 2 paper towels. To begin Session 2, take the bags of butyl stearate from the pails of warm water and set each bag on a paper towel right before you distribute them to the teams. Give each team of 2 a bag of butyl stearate, a tumbler, and 2 paper towels. Instruct students not to open the bag of butyl stearate, but to look at it closely. Make sure they notice that it is in the liquid state. Ask, what do you predict will happen if you put the bag of butyl stearate into a tumbler of ice water? The students may say that the butyl stearate will become solid. Have students record their predictions on the activity sheet. Next, instruct students to fill their tumblers half full with ice water and to place their unopened bags of butyl stearate in the ice water. Give each team their 1-ounce plastic cup of frozen water from Session 1. Ask students, what happened to the water? They should respond that the water has changed to a solid or ice. Ask, what is happening to the butyl stearate? Students should see that the butyl stearate is in the process of changing to a solid. Have students continue to observe the butyl stearate until it is completely solidified, which may take about 10 minutes. Then, instruct the students to remove the bag of butyl stearate from the water and place it on a paper towel, and record on the activity sheet what happened to both the water and the butyl stearate. Ask students, what did you do to the liquid water and the butyl stearate to change it to a solid? They should say that they cooled, or took heat away from, both. Define freezing for the class as the changing of a liquid to a solid by removing heat from the liquid, and point out that the opposite of freezing is melting. Have students observe what is happening to the ice and butyl stearate. They should notice that both the ice and butyl stearate are beginning to melt. Instruct students to discard the ice water from their tumblers, refill them half full with warm water, and place their bags of butyl stearate into the tumblers of warm water. Have them observe what happens to the butyl stearate and record their observations on the activity sheet. After they have recorded their observations, ask students, what happened to the butyl stearate when it was placed in the warm water? Students should notice that the butyl stearate began to melt. Point to the changing states chart and remind the class that the change of state from solid to liquid requires added heat, in this case, the heat from the warm water. Next, review evaporation and condensation of water vapor from previous activities. Remind students that when a pure substance changes from one state to another, that substance does not change to any other substance. For example, water is always water, whether it is in the state of solid, liquid, or gas. Stimulate a discussion by asking, what are some other times when you have seen liquids freeze or change from liquids to solids? Students may mention water freezing on puddles, icicles forming on the edge of a roof, or fruit juice freezing into popsicles. Explain that all liquids can change state to solids if enough heat is removed from them. Finally, refer students to the changing states chart. Draw an arrow from liquid to solid and write the word freezing under the arrow. Guide students to understand that in both freezing and condensation, heat is taken away to make the change of state. To conclude the activity, rinse and dry the cups and containers and then return all materials to the kit. Make sure to save the bags of butyl stearate for future activities. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.